Welcome to math class. If you like our videos, don't forget to subscribe. This video is about trigonometry. Hi there. Today we are going to learn how to use trigonometry to find the lengths of sides in right-angled triangles. We will be focusing on three key ratios: sine, cosine, and tangent. These are very important because they help us solve problems where we know one or more angles and some of the side lengths. Let's start with this right-angled triangle. The sides of the triangle have special names. The first one is the longest side, which is opposite the right angle and is called the hypotenuse. Second is the side opposite the angle we are working with. It is called the opposite. The remaining side, which is next to the angle, is called the adjacent. You would have remembered this from our last topic in Pythagoras. We use these names because they will help us use the trigonometric ratios to find the missing side lengths of the triangle. When working on trigonometry questions, try to turn the page that you can see both the right angle and the known angle are horizontal. From there, you'll be able to identify the three different parts of the right-angled triangle. Let's learn the three rules now in trigonometry, knowing the trigonometric ratios. The three trigonometric ratios you need to know are: first one, sine. The formula is sine theta equals opposite over hypotenuse. Second one, cosine. Formula, cos theta equals adjacent over hypotenuse. The third one is tangent. It is tan theta equals opposite over adjacent. To remember this, use the acronym SO-CA-TOA. As my teacher used to say, some old horse caught another horse, taking oats away. Here, theta, the symbol that looks like the letter 0 that has a line through it, represents the angle you are working with in the triangle. Let's start with sine. If you're given an angle and the hypotenuse and you need to find the opposite side, you can rearrange the sine formula to the one showing here. Opposite equals sine times hypotenuse. Let's have an example. Sine 30 equals opposite over 10. To work this out, we substitute the unknown as x over 10. Now what can we see? It's an equation, and from knowledge in using equations, the denominator you need to multiply with the answer to find x. Therefore, we times 10 with sine 30 and our answer is 5. To work out the sine, cosine, and tangent values for the given angles, you will need to use a calculator. Next, let's use cosine. If you know the angle theta and the hypotenuse, all you need to find is the adjacent side. You can rearrange the cosine formula to the following. Adjacent equals cosine theta times hypotenuse. Let's say the angle is 60 degrees and the hypotenuse is 12 centimeters. We need to find out the adjacent side. So the unknown will substitute it as x, and again we see it as an algebraic fraction. We can see there is the dominator that we can multiply with the answer, which is cosine 60. So to find x, we have the denominator times the answer, which is 12 times cosine 60, and the answer will be 6 centimeters. Lastly, let's do the tangent formula. If you know the angle theta and the adjacent side, and you need to find the opposite side, you can rearrange the tangent formula to this. Opposite equals tan theta times adjacent. Let's say the angle is 45 degrees and the adjacent side is 8 centimeters. We need to find the opposite side. We use the tangent formula. Tan 45 equals opposite over 8. We can be certain the unknown as the letter x, and again we put it as a fraction. Therefore, we will have the denominator 8 times tan 45, and the answer will be 8. So we have completed the first part of trigonometry, where we have the value as the denominator. Let's turn this around and see what happens if we have the unknown as the denominator. So let's use that example for sine here. I have my unknown hypotenuse, which is x, my opposite, which is 3.41, and my angle is 43 degrees. Let's set it out so we know it's sine. So we write sine 43 degrees equals 3.41 over x. Let's use the same knowledge as we did in algebraic fractions. We have the denominator times the answer. So here, x times sine 43, bottom times top. The answer will be sine 43, x equals 3.41. We can see the value and pronumeral next to each other. Sine 43x. And from algebraic knowledge, when a number next to a letter, there is an invisible symbol in between which is multiply. From our past knowledge, the opposite of multiply is divide. So here we will leave x by itself. X equals 3.41 divided by sine 43. Therefore, our answer will be 5. In this example, let's use cosine. I have my unknown hypotenuse, which is x, my adjacent, which is 8, and my angle is 60 degrees. Let's set it out so we know it's cosine. So we write cos 60 degrees equals 8 over x. Let's use the same knowledge as we did in algebraic fractions. We have the denominator times the answer here. So x times cos 60. Again, bottom times top. The answer will be cos 60x equals 8. We can see that a value and pronumeral next to each other. Cos 60x. And from algebraic knowledge, a number next to a letter, there is an invisible symbol in between which is multiply. The opposite of multiply is divide, so here we'll leave x by itself. X equals 8 over cos 60, so our answer will be 16. Lastly, let's use that example for tangent here. I have my unknown adjacent, which is x, my opposite, which is 7.55, and my angle is 40 degrees. Let's set it out so we know it's tangent. We have got the formula here, tan 40 degrees equals 7.55 over x. Applying the knowledge of algebraic fractions, we have the denominator times the answer, x times tan 40, bottom times top. The answer will be tan 40x equals 7.55. The value and pronumeral again is next to each other. Tan 40x. The invisible symbol in between is multiply. The opposite of multiply is divide. We leave x by itself. X equals 7.55 over tan 40. Our answer will be 8.99. To summarize, sine helps you find the opposite side when you know the hypotenuse. Cosine helps you find the adjacent side when you know the hypotenuse. Tangent helps you find the opposite side when you know the adjacent side. Remember to always check which sides you have and which side you are solving for. Then, choose the appropriate trigonometric ratio. Make sure you use a calculator to find the sine, cosine, and tangent values for the given angles. Thanks for joining me today. See you next time.